Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
My feel out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Listen, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 147 of the Space Rocket History Podcast. And now, Saturn S2 Stage Part 2. The S2 stage was a nightmare the minute it was conceived, and it only got worse from there. During the course of its creation, it would grind up people and careers the way the transcontinental railroad devoured laborers. Though the methods and materials used to build the S2 were reasonably well known, nobody had ever tried to apply them on such a titanic scale. Originally, it was to be somewhere around 8 stories tall with a diameter of 22 feet, but the width ballooned from there to 27 feet before the contract was even signed, then to 30, and finally to 33 feet. And all the while, as the size of the thing increased, NASA was trimming the allowable weight. End quote. That was a paraphrase comment of Harrison Storms from North American Aviation. As the weight of the Apollo payloads relentlessly climbed during the early 60s, NASA engineers redoubled efforts to lighten the stages. To get 1 more kilogram of payload, the laws of orbital mechanics required that 14 kilograms be cut from the S1 or 4 to 5 kilograms from the S2, but only 1 from the S4B. However, the S4B stage was already in production when the weight problem became acute. It was too late to slice anything from that stage, where the advantage was greatest. Trying to scrape 14 kilograms out of the S1 to save 1 kilogram of payload just was not feasible in terms of time and effort. That left the S2 stage. As the second stage became a more finely honed and thin-shelled vehicle, the balance between success or failure became more delicate. This was especially true when welding the large, thin tank skins of the S2 stage. As I mentioned in last week's episode, another persistent problem centered on the insulation for the liquid hydrogen tank. Marshall Space Flight Center technical monitors became increasingly concerned during the spring of 1964 and reported considerable difficulty in perfecting adequate liquid hydrogen tank insulation. The growing problem crept up unawares, so to speak, and was first reported on a memorandum dated June 2, 1964. Quoting from the memo, quote, "The S2 stage insulation concept for vehicles 501, 502, 503, and to a somewhat lesser extent for the S2 ground test vehicles has not been fully qualified as of this date." This fact was discovered by Marshall personnel and came as quite a shock to the North American management, and needless to say, to Marshall. End quote. The memo noted a number of anomalies, chief of which was the debonding of the nylon outer layer from the honeycomb material underneath when exposed to a simulated flight environment. The insulation difficulties became symptomatic. More serious production troubles appeared starting in October 1964, when burst tests revealed welded cylinder specimens lower in weld strength than anticipated. Then, on October 28, 1964, the first completed aft bulkhead for the S-2 structural test vehicle ruptured during a hydrostatic proof test, although at a lower pressure than specifications dictated. The fault was traced to a previous repair weld done by hand along a recirculation system service plate while welding of a replacement bulkhead proceeded. A design change eliminated the welded service plate, making it an integral part of the bulkhead gore. But the continuing snags involving the S-2 began to cause great concern for managers at Marshall and NASA headquarters. In particular, was the need to get the first S-2 flight stage, S-2 number 1, out of the door at Seal Beach, tested and delivered to Cape Kennedy for the first Saturn V launch, AS-501, in 1967. Production troubles with the S-2T, the ground test stages, by late 1964 and early 1965, threatened the S-2 number 1 so much that Marshall's director, Werner von Braun, proposed a reworking of the whole S-2 test program to make up some of the slippages. From the vantage point of Major General Samuel C. Phillips, the director of the Apollo program in Washington, concurred and set in motion a series of shortcuts in the spring of 1965 to put the S-2 schedule back in shape. Specifically, NASA decided to cancel the dynamic test stage called S-2D and instead use the S-2S, the structural test stage, for this purpose after its structural test. This decision greatly relieved both manufacturing and assembly pressures on flight stages at Seal Beach and permitted use of S-2D hardware in follow-on stages. Further, the all-systems test stage bypassed its scheduled test at Santa Susana and was scheduled for direct delivery to the Mississippi Test Facility. Meanwhile, the S-2F, the facility checkout stage, was scheduled to bypass Mississippi altogether for delivery direct to the Cape. There, the S-2F would be pressed immediately into service to give Launch Complex 39 a thorough and complete checkout before the first flight stage arrived. In addition to relieving pressure on the schedule, these changes netted a savings of $17 million. Following these early deviations, the S-2 program appeared to be proceeding well until Marshall decided in May to freeze the configuration of the S-2. Explaining the decision, Arthur Rudolph, Saturn V program manager, said that because production hardware was in the process of fabrication, engineering change activities on vehicles and ground support equipment should be frozen to the present baseline configuration. Henceforth, only absolutely mandatory changes would be tolerated. During the spring and summer of 1965, there was reason to be encouraged by the progress of the S-2. But welding continued to be troublesome. Early in July, North American began preparations for making the first circumferential welds on the S-2 number 1. After completing the operation on July 19th, the weld was found to be faulty and repairs stretched into the first week of August before additional work on the S-2 number 1 could be started. Then, the first incident in a chain of misfortunes occurred that created one of the most serious times of trouble in the development of the Saturn V. On September 29, 1965, the S-2 structural dynamic test stage ruptured and fell apart during a loading test at Seal Beach. Destruction of the stage transpired during a test to simulate the forces acting on the stage at the end of the S-1 boost stage. Marshall quickly organized an ad hoc group to determine the reasons for the accident, tagging it with a rather dramatic title, the S-2 Structural Dynamic Test Stage Catastrophic Failure Evaluation Team. Additionally, Marshall added a debris evaluation team to help pinpoint the component that caused the failure. When the catastrophic failure evaluation team started sifting reports, it was eventually determined that the point of failure had been in the aft skirt area at 144% of the limited load. Even though considerable data had been accumulated on this particular test and earlier tests, the loss of the stage left a void in the planned vehicle dynamic test at Huntsville. The test program was juggled around to use the S-2 test stage instead, following the static testing at Mississippi. The loss of the S-2S structural test vehicle and continuing difficulties with the S-2 at Seal Beach caused increasing consternation at Marshall. When the president of North American, Lee Atwood, visited von Braun in Huntsville on October 14th, he found an indignant mood prevailing at Marshall. Brigadier General Edwin O'Connor, director of Marshall's industrial operations, provided von Braun with some background data that included the following judgment, quote, "The S-2 program is out of control. It is apparent that management of the project at both the program level and division level at North American has not been effective. In addition to the management problems, there are still significant technical difficulties in the S-2 stage," end quote. Obviously concerned, von Braun extracted promises from Atwood to put both a new man in charge of the S-2 program and a senior executive in a special position to monitor the plethora of technical delays and manufacturing problems. In October of 1965, Harrison Storms, the president of North American's division building the S-2, received a letter from General O'Connor. The general minced no words. He pointed out that the breakdown in the S-2 program reflected poorly on both North American and Marshall's management ability. O'Connor pointed a stern finger at North American, remarking that he was most apprehensive about the entire S-2 program. The continued inability or failure of North American to project with any reasonable accuracy their resource requirements, their inability to identify in a timely manner impeding problems, and their inability to assess and relate resource requirements and problem areas to schedule impact, led the general to the conclusion that North American management does not have control of the Saturn S-2 program. The general also conveyed his concern about the troublesome stage to the upper echelons of NASA management. Reviewing the problems during the annual program review at headquarters in November, General O'Connor noted managerial and technical shortcomings at North American and said that Marshall had caused changes to be made in management. Some people have been moved. In spite of help from the R&D Operations Laboratory at Marshall, problems in welding, inspection, installation, and component qualifications still existed, and as a result, the first S-2 flight stage was more than 3 months behind schedule. Further, it was the general's opinion that program management at North American was perhaps the principal shortcoming of the entire S-2 program. Well, what does NASA usually do when things get this bad? Of course, they create and dispatch a Tiger team. This one headed by General Phillips from the Apollo Program Office. The result of the Tiger team's visit to North America was the soon-to-be famous Phillips Report, which ripped into the company's management not only on the S-2 matter, but on the command and service module as well. The impetus for this penetration of North America was a byproduct of a meeting of the President's Scientific Advisory Committee, headed by Jeremy Wiesner, which convened at the Manned Spacecraft Center in Houston on October 15, 1965. Since a covey of high-level NASA executives was attending, Phillips took advantage of the situation by assembling a select group for an intense one-hour session following the President's Science Advisory Committee sessions. The participants included George Miller, George Loss, and Joe Shea from headquarters, along with von Braun's deputy, Eberhard Rees from Marshall. The issue was North America's performance on the S-2. Rees briefed the group on plans to send a group of selected experts from Marshall to check on North America's operations on the S-2. The Marshall group scheduled to leave on October 18th was headed by Colonel Sam Yarchin, the program manager at Huntsville. Phillips wanted more than that. Rees reported that aside from Marshall's own S-2 sleuths, Phillips wanted to take a close look at the entire North American operation. After Yarchin's committee had done some initial work, Phillips advocated a special survey team composed of top management from both Houston and Marshall. On October 27th, NASA Associate Administrator Miller wrote to Lee Atwood advising him of what was coming. Miller noted their mutual concern that the Apollo program should stay on course to a successful conclusion, but he stressed severe problems in the rate of progress for both the S-2 stage and the command and service modules. The purpose of Phillips' visit was to identify those actions that either or both of them should take. General Phillips took Joe Shea from NASA headquarters and Rees and O'Connor from Marshall. The group went to North American on November 22nd, and their report was due before Christmas. As a side note, this is when Stormy had his heart attack. The Phillips report, as it became known, was dispatched to Lee Atwood over Phillips' signature on December 19, 1965. Briefly, Phillips told Atwood, quote, "I am definitely not satisfied with the progress and outlook of either program. The conclusions expressed in our briefing and notes are critical." End quote. The overall report was a thorough analysis of North America's operation, with various sub-teams investigating management, contracting, engineering, manufacturing, and reliability quality control. Including Yarchin's initial work on the S-2, completed in early November, the thick document represented an almost unrelieved series of pointed criticisms of North American. Phillips offered one small ray of hope. Quote, "The right actions now can result in substantial improvement of position in both programs in the relatively near future." End quote. At this crucial juncture, Arthur Rudolph, head of Marshall's Saturn V program office, concluded that the S-2 should not be starved for funds in the midst of its crisis, and began massive infusions of dollars into the S-2 project for overtime, increased manpower, R&D, and whatever else it took to get the job through. Eberhard Rees was prepared to invoke draconian measures unless the situation at North American showed distinct improvement. On December 8, 1965, he composed a 13-page memo titled Personal Impressions, Views, and Recommendations. The memo was based on his findings at North American. In Rees' opinion, the operation was far too big and bulky. It needed to be slimmed down, and there needed to be much more awareness of progress and problems at the corporate level, which seemed to be dangerously insulated from its various divisions. In general, Rees seemed to view the situation with greater alarm than most. He wrote, "It is not entirely impossible that the first manned lunar landing may slip out of this decade, considering, for instance, the present status of the S-2 program." End quote. Rees obviously had further thoughts on the dire possibility, for on the next day he prepared an additional 7-page memo and attached it to the first. In the memo, Rees advised that Marshall should keep very close watch over North American, and if their performance did not improve in 1966, then Rees wrote, quote, "I believe NASA has to resort to very drastic measures and should in all seriousness consider whether further S-2s should be contracted with North American." End quote. The bulk of S-2 manufacturing facilities were owned by the government and could, if need be, turned over to another contractor in whom we have higher confidence. For me, it is just unbearable to deal further with a non-performing contractor who has the government tightly over a barrel, especially when it comes to a multi-billion-dollar venture of such national importance as the Apollo program. End quote. With so much trauma surrounding North American's effort in the S-2 and Command and Service Module programs, a realignment of the company's managerial structure seemed inevitable. Already trying to get on top of the S-2 program in 1965, Storms named Robert E. Greer, a retired Air Force Major General, as his special representative for the S-2. Greer had joined the company in July and took this assignment in October. By January of 1966, in the wake of the Phillips Report, Greer became Vice President and Program Manager of the S-2 program. In a somewhat unusual turn of events, the man Greer replaced, Bill Parker, stayed on as Greer's deputy. Parker had joined the company in 1948, serving as S-2 program manager since 1961. The company's management obviously hoped that Parker's strong background in engineering and years of experience inside the company would complement Greer's managerial skills, recently honed as Assistant Chief of Staff for Guided Missiles at the U.S. Air Force Headquarters. In retrospect, Greer observed that the S-2 program was indeed in bad shape. Among other things, he said that the top management had poor visibility and the lateral flow of information seems to be very weak. Greer updated and revitalized his Management Control Center to enhance management's overall concept of progress, or lack of it, in the S-2 program. He also instituted more management meetings, carefully structured to help the lateral flow of information as well as garner intelligence from a broader range of sources, vertically as well as laterally. The meetings were known at North American as Black Saturdays, which was essentially a meeting with high and low echelon people at the same time, so everyone could know and understand what the goals and challenges were. Greer felt the situation so desperate that he had Black Saturday meetings every day, though he eventually changed it to 2 or 3 times per week. A wide variety of problems were discussed in these meetings, with planners and assembly line engineers exchanging criticisms and recommendations. The experience spotlighted a lot of otherwise hard-to-see conflicts and certainly improved overall visibility and awareness of the S-2's development. Greer also made a point of personally visiting people at lower echelons of management and engineering to enhance employee morale and accumulate additional information for himself. In any case, Greer won the respect and admiration of many of his contemporaries at North American. Nevertheless, Greer's new administration took time to bring all the discordant notes of the S-2 program into closer harmony. Growing restlessness spread through NASA headquarters as the S-2 #1, the first flight stage, became the pacing item for AS-501, also known as Apollo 4. As it turned out, the really difficult problem became the S-2 test stage, which at present was undergoing testing at Mississippi. In April, one of Phillips' envoys at Mississippi reported serious problems in North American's personnel. The veteran group of test people sent to Mississippi on a temporary basis had gone back to California, leaving inexperienced personnel in charge. On May 25, 1966, one fire near some liquid hydrogen valves and another in the engine area curtailed a full-duration static test. 1967 was a year of contrast for the S-2. During January, Phillips reported to the Office of Manned Spaceflight that organization and test procedures had improved at Mississippi. To cope with the continuing problems at Seal Beach, Marshall sent a new Tiger team under the leadership of Colonel Yarchin, the S-2 project manager. Yarchin and 15 well-known technicians left early in January. By the end of the month, Phillips reported to the associate administrator that Marshall's welding techniques had been adopted on the S-2. Then, in January of 1967, the Apollo 1 disaster occurred. The Apollo 1 fire triggered further reorganization of North American as the company continued to contend with the persistent criticism of its performance from NASA. In a series of moves announced early in May 1967, company president Atwood streamlined North American and drastically shuffled his management team. Harrison Storms was replaced by Bill Bergen, who had only recently resigned as president of the Martin Company. Bergen was given the assistance of some of North American's top executives. Paul Voigt, newly appointed vice president in the Space Division, had special responsibility for improving engineering, manufacturing, and quality control. Ralph Rudd, an expert on materials and quality control and former corporate vice president for manufacturing, took over as Bergen's executive vice president. In addition, North American management at the Cape was realigned into a more unified structure, reporting directly to Bastian Hello, who came with Bergen from the Martin Company. In the meantime, delivery of the S-2 #1 stage to the Cape in late January prompted cautious optimism about the overall progress for the Saturn booster. However, this optimism was short-lived due to the continued requirements for change work on the stage after it had already been delivered. As an example of these after-delivery problems, tiny hairline cracks were found in an S-2 while being manufactured. This led to concerns about similar faults occurring in the S-2 #1, which was already in the stack with the other stages for the Apollo 4 launch. With the launch scheduled for mid-August, individuals meeting at NASA headquarters on the afternoon of May 24th considered the possibility of missing the launch date because of the inspection work to be done on S-2 #1. The top-level decision group, including Phillips, von Braun, DeBus, O'Connor, Rudolph, and Yarchin, came to the only safe decision: take down the S-2 #1 and conduct extensive dye-penetrant and X-ray inspection of the welds in the liquid oxygen and liquid hydrogen tanks. The inspection uncovered a dozen imperfections requiring careful tank repairs and burnishing of the tank walls. The original August launch date for Apollo 4 kept slipping, but other modifications were also made to the rest of the vehicle and the ground equipment, so it was not the sole fault of S-2 #1 that Apollo 4 did not leave the pad until November 9th, 1967. In conclusion, North American had trouble with the S-2, at least in part because the company had some management difficulties. In fact, the problems had been growing many months before the crisis of 1965 through 66. Von Braun's daily journal expressed concern about management shortcomings as early as 1963, citing problems in cost overruns and organization of manufacturing units. Moreover, the S-2 program got caught in a weight-shaving program, which made working with its extremely thin-walled tanks and other lightened hardware even more difficult. The turnaround for the S-2 by 1967 resulted from the resolute, though agonizing, reorganization of North American's management. The reorganization created better visibility and more direct interaction between corporate managers and the divisions, and benefited from the streamlining of North American itself, and of course the ability of Robert Greer. Greer's combination of managerial skills and the ability to come to terms with the technical problems commanded the respect, loyalty, and performance from North American's workers at a crucial time. North American was competent to do the job. Reorganization and tighter management enabled North American's capabilities to be applied more effectively. Finally, the influence from NASA headquarters and from Marshall was extremely significant. The thorough assessment by the Phillips team influenced North American's realignment in the right direction. Added to this was the impact of various technical teams from Marshall dispatched to Seal Beach and Mississippi to help solve perplexing hardware problems and operational snares. In spite of all the early predicaments in the Saturn program caused by the S-2, the Saturn V nevertheless launched men to the moon within the decade, and the S-2 stage, along with other Saturn components, compiled a perfect record of successful missions. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.